Hi guys, in an earlier video we had talked about one way to write the equation of a line, namely standard form. Okay, today we're going to talk about a different way to write the equation of a line, and in this case, as you guessed it, slope-intercept form. Okay, so slope-intercept form. So an equation is said to be in slope-intercept form if it looks like this: y equals mx plus b. So we have seen x and y. You know, those are the variables in our equations. M, recently new to our life, m is a notation that we use to represent slope. Okay, so an equation is said to be in slope-intercept form if it's written like this: y equals mx plus b, where m represents slope and b reminds me of nothing. So I'm just gonna have to have in the back of my mind that b represents the y-intercept. Cool. Let's do this. So we're not quite ready to introduce another technique to graph a line. What we are going to do, we're gonna look at these lines and then figure out what's an equation, and then the question is, how should we write the equation? Should we put it in standard form or in slope-intercept form? And in this case, we're gonna write them in slope-intercept form. So it says example number 3. Someone made a typo. We don't call them examples, we call them fun problems. I need to fire myself. Okay, I'm my own secretary. So fun problem. So it says write an equation in slope-intercept form if possible for each of the lines shown below. Okay, so that if possible really throws me off. So we have some graphs. I need you to give me an equation, write it in slope-intercept form, but I guess if for some reason, if it's not possible to write in slope-intercept form, then just do what you gotta do. Okay, so coming to problem A. So we want to write the equation in slope-intercept form: y equals mx plus b. So gentle reminder where m represents the slope and b represents the y-intercept. So new to my life, I have to remind myself what b represents. It is the y-intercept. So again, flashback, what is y-intercept? The y-intercept is the point where the line intersects the y-axis. So in this case, let me go ahead and identify the y-intercept. So for problem A, the graph intercepts the y-axis at -2. So the y-intercept, sorry, I meant to put a dash. The y-intercept is at -2, which means that b equals -2. To write an equation in slope-intercept form, we have to identify the slope, we have to identify the y-intercept. We already nailed the y-intercept, now we have to nail the slope. So slope, remember, how should we calculate it? You have two options. One, you can use the slope formula, but I'm going to give you a secret. If a graph is provided, then just compare the ratio of rise to run. But if you want to make things a little bit more difficult, then go ahead and use the slope formula. It's your grade. Cool. So slope, ratio of rise to run. Okay, so whether we use a slope formula or we compare the ratio of rise to run, we still have to identify or highlight 2 points. So in this case, I'm going to use the points that are highlighted on the graph, which is the point at 0, -2, and at -3, 0. Okay, so I'm going to, yeah, that doesn't stand out. Let me go ahead, see if I can zoom in. Okay, that's as big as it's gonna get. I think that's a little bit better. Okay, so I'm gonna go ahead, label these like 0.1 and 0.2. I don't really care how you label them, but I'm gonna label them in the order that I see them as viewed from left to right. So first I see, yeah, that doesn't really work. Okay, let's take my bookmarker. Okay, yeah, that's a distraction too. So first I see this point right here, so I'm gonna call that 0.1. And then I see that point at 0, -2, so we're going to call that 0.2. So slope, ratio of rise to run. So let's see what that rise is. How many units do we have to go up or down to be at the same height as the second point? Run. How many units do we have to go side to side to get to our mark? So if I was willing to show my face, then I would show you my hand gestures, but that's not happening. So let's do this. Rise. How many units are we going up or down to be at the same height? So in this case, I think we have to go down 1, 2 units. Okay, so because we have to go down 2 units, then our rise will be -2. Sorry, I'm having technical difficulties. Okay, so our rise will be -2. Cool. So once we go down 2 units, we're gonna be at that same height. run, how many units will we have to go side to side to get to the mark? So in this case, we're gonna have to go to the right. So we're gonna have to go down. We have to go down. We have to go to the right. 1, 2, 3 units. Okay. So because we went 3 units to the right, then our run is positive. Okay, so the moral of the story is that the slope of this line is negative 2/3. So we needed to find the slope. Done. We needed to find the y-intercept. We got this. Let's go ahead and earn our full credit. So let's go ahead and write this equation in slope-intercept form. So y equals mx plus b. So we have y equals, the slope is negative 2/3. That's our m. We're going to multiply that by x, and then we're going to add to it b. So the y-intercept is at negative 2. So the our b is negative 2. What I just wrote is correct, but whenever you give me your answers, I need them as clean cut as possible. So this plus negative number doesn't really work for me, so I would really appreciate it if you just put -2. So the preferred answer is y equals negative 2/3 x. Instead of adding -2, we're going to go ahead subtract -2. So again, is my earlier entry incorrect? It's not, but it could be simplified further. So if you can simplify it further, that's what we need to see. Okay, 1 problem down, 3 more to go, and we're out. Cool. So for problem B, we have another nice graph. We are asked to write it in slope-intercept form. So I gotta remind myself, an equation is said to be in slope-intercept form if it looks like this. Y equals mx plus b, where m is our slope and b is our y-intercept. It doesn't matter which of the two you find first, just you gotta find them both. For me, it's easier to identify the y-intercept first, so that's what I'm gonna nail. So our y-intercept, because the line intercepts the y-axis, which I forgot to pencil in. Okay. Because our graph intercepts the y-axis at 0, then our y-intercept is at 0, which means that the value of b is 0. So 1 down, 1 more to go. Slope, ratio of rise to run. So slope, ratio of rise to run. Okay, so let's go ahead, highlight any 2 points. You can either look at the ones that are highlighted, or you can just use 2 that are closer. I'm going to look at the ones that are highlighted. Actually, no, I don't want to count too much. So we're going to just highlight this one right here. Are we going to get a different answer? Well, we shouldn't, because the steepness of the mountains is not changing. Okay, so slope, ratio, rise to run. Which one should I label as my first and second point? That's a personal choice. You know my speech. I label these in the order that I see them from left to right. So first I see that bottom one, so that's going to be our first point. Then I see that top one, so that's going to be our second point. So point 1, point 2. Do you have to label? No, I mean, do what you got to do. So slope, ratio of rise to run. How many units are we going up or down to be at the same height? And then how many units run? How many units are we going side to side to get to our mark? So if I start at point 1, to be at the same height as point 2, we're going to go up 1 unit. So our rise will be +1. Now that we're at the same height, how many units are we moving side to side to get to our mark? So in this case, after we go up 1 unit, we're going to go 1 unit to the right. So because we went to the right, then our run is going to be positive as well. So the slope, ratio, rise to run, our rise is +1, our run is +1, and that can be simplified to just 1. So again, if you can give me an integer slope, go for it, and if you can't, just reduce it. So we have an equation is said to be in slope-intercept form if it looks like this. Y equals mx plus b. So in this case, the slope is 1. So we're going to put 1 times x plus our y-intercept of 0. So this is correct, but as stated, your answers need to be as clean cut as possible. I know that you know that 1 times x is x. And then adding 0 is not going to change the bill. So the preferred response is y equals x. Fantastic. So I think we're cool, but we're going to put 2 more spicy problems and then we're done. Okay, let me zoom out. Problem C for the almost grand finale. Remember to pause and rewind as many times as needed. So we are asked to write this equation in slope-intercept form. Y equals mx plus b. So let's identify the slope and then the y-intercept. So in this case, what is the y-intercept? So the graph intercepts the y-axis at 2. So our y-intercept is at 2. Okay, in terms of the variable, it's a b. Okay, b represents the y-intercept. Now we have to find the slope. Okay, so let's identify the slope. Slope ratio of rise to run. Okay, we have 2 points that are highlighted, but how about if I use this one and then we're gonna make up not make up, but we're gonna highlight our own point. Again, it's not gonna change the steepness of the line. If you don't trust yourself, then I guess use the ones that are highlighted. So I'm going to label them, you know, the speech in the order that I see them from left to right. So first I see the one on the left, so that's point 1, and then that red one, that's point 2. So point 1 and point 2. So slope, ratio of rise to run. Rise, how many units are we going up or down to be at the same height? Run, how many units are we going side to side to be at our mark? So in this case, rise, I'm like, how many units am I gonna go up or down to be at the same height? And that's a trick question. We're already at the same height, so we don't have to go anywhere. So the rise, we don't have to go anywhere vertically. So the rise is gonna be 0. Okay, run, because we have to pull 1 unit to the right, then the run will be positive. Okay, and in this case, the quotient of 0 and 1 simplifies to 0. Okay, so we needed to find the slope. Done. We needed to find the y-intercept. We already did. Let's plug in chug. Okay, so we have y equals m. Our slope is 0 multiplied by x plus b, which is the y-intercept, and the y-intercept is at 2. Product of 0 and x, that just looks weird. Simplify it. That's it. It gives us 0. Okay, there's no x. So I guess this is why in the directions it says write the equation in slope-intercept form if possible. So like if the variable cancels out, you're not having a moment. Okay, for the grand finale, because it's been a long day. So again, the ultimate goal is we want to write the equation in slope-intercept form if possible, and we saw that it was not possible. Okay, so let's identify the slope and y-intercept. Okay, so we have, where am I? We want to find the y-intercept. So where does the line intersect the y-axis? So the graph does not intersect the y-axis, so there is no y-intercept. So I'm like, let me move this. Okay, there is no y-intercept, so that makes me sad. Okay, what about the slope? Slope, ratio of rise to run. Okay, so let's go ahead, highlight 2 points. We can either use the ones that are actually highlighted, or you can just highlight your own. I'm going to take that one that's in the bottom highlighted, and then I'm going to highlight this one, just one tick mark above. I'm going to label these as point 1 and point 2. So slope, ratio of rise to run. Rise, in this case, we're gonna go up 1 unit. To be at the same height. So our rise will be positive 1. After we go up 1 unit, I'm supposed to say, what is my run? How many units are we going side to side to get to our mark? But this is the thing. As soon as we go up 1 unit, we're already at the mark. So we don't have to go anywhere side to side. So our run is 0. And the quotient of 1 and 0, another funny surprise, is undefined. So the question is, well, what am I going to do? I'm like, I don't know, because we haven't attacked something like this. So I'm just like, all right, I'm going to plug and chug like we did for A, B, and C. So the slope, undefined. What am I going to do with a slope? Oh, multiply it by x. And then add to it b. What is that? The y-intercept. But there's no y-intercept. So I'm having a moment. So for this problem, it is also not possible to write the equation in a slope-intercept form. Y equals mx plus b. But what makes it tougher is that I can't just be like, cancel and I'm good. So we're going to have to be creative. I don't know how, so let me just go ahead, label these ordered ordered pairs. Let me order these points. Sorry. So it's point 1. In terms of the ordered pair, it's a -3, -3, -3, -3. Okay. Point 2, that's -3, -3. In this case, I want to point out what is it that you see that's the same? Is it like the x values that are the same? Is it the y values that are the same? In this case, the values of x are the same. But that's actually not like a coincidence. We have a vertical line, okay? And what's so special about the ordered pairs on the vertical line? No matter where we are on the vertical line, the value of x, let me just put xy and xy. I'm going to pretend you can read that, okay? No matter where we are on the vertical line, the value of x has to equal -3. X, -3, x equals -3. What about this point that's highlighted? What's the value of x? -3. Okay, so what has to hold true? X always has to equal -3. Well, let's put it in writing. What has to hold true? X equals -3. Okay, and that will be the equation of the graph provided. And if you're feeling like, nah, I don't really feel it, what if I got it wrong? Then graph it, okay? Do an XY table, and then you're gonna get that same vertical line. Okay guys, so I said we were going to do 4 problems. That's our 4th problem, so we're out. Thanks.